Thank you everyone for allowing me to present here in APCORE 2018. The research topic that I will be presenting is Principal Component Analysis on the Impact of Renewable Energy and Tourism Integration to the Livelihood Transformation of Ilocos Norte residents. Ilocos Norte is a province in the Philippines, where I came from. I also work in the locality, and I have seen the sudden increase in the tourism activity due to the presence of the renewable sites. Tourism ranked third on the most important sector globally and a major economic resource. Tourism generates investment, creates jobs, encourages foreign exchange, among others. Initially, the major source of income is farming and fishing, since Philippines is an agricultural land. Tourism gave additional income to the locals, wherein they can be tour guides, tourist drivers, be employed in the accommodation sector, or into a small cottage industry of building souvenir shops. In the photos, you can see a lady cooking a famous local snack called empanada. Another photos are horseback riding of tourists in the hilly areas of the province, a lady selling souvenir items near the wind farm, a local farmer, and the photo of our Governor Amy Marcos, who spearheaded the aggressive tourism program a decade ago. But where is Ilocos Norte? Actually, it is not that far. It is very accessible. It is only 9 to 12-hour drive from Manila. If you are taking the plane, it will only take you for 1 hour. There have been a massive tourism campaign around a decade ago that included TV ads on local and national channels, billboards on main roads, social network, festival promotions, among others. The tourism program is dubbed Paway Kumakaway from the word Paway, a town, and waving of hand Kumakaway. It was launched on March 1, 2011 and was institutionalized by the provincial government through the initiative of Governor Amy Marcos to promote Ilocos Norte's various beautiful and historical places and delicious foods to tourists and visitors. So these are some of the famous attractions in Ilocos Norte. One is the St. Augustine Church, or more popularly called the Paway Church in Ilocos Norte. It is one of the oldest churches in the Philippines and considered as a UNESCO World Heritage Site. Kapurpuruan White Rock Formation was formed of years ago by accumulation of particles deposited to the shore by the forces of sea waves, winds with the aid of gravity and time. It is a very long process known as sedimentation. The term Kapurpurawan is from Ilocano word purao, which means white. Wind and solar farm are also within the site. Pagudpud is a white sand beach and a crystal blue water that makes the place a heaven for tourists. It is dubbed as the Boracay of the North. Wind and solar energy are briskly being the current trend in renewable energy. The province now has around 280 megawatt of wind power and around 30 megawatt of solar power, contributing substantially to the energy source mix of Ilocos Norte. This has made the province the renewable energy capital of the Philippines. There are 4 towns with renewable energy sites. Thus, gathering of data were concentrated also on these towns. You may notice that the 3 sites are located up north. Northern part of Ilocos Norte is one of the windiest sites in the Philippines. You can see the dark-colored shaded areas are those that have good wind resource potential. The North Wind Farm was operational on May 2005. The power plant gave the locals employment during construction of the wind plant, and local benefits from the visiting tourists by making and selling wooden wind turbine souvenirs. This 150 megawatt power plant is the biggest and largest wind farm in Southeast Asia to date, which started its construction in 2013. The 81 megawatt wind farm composed of 27 wind turbines of North Luzon Renewables in Pagudpud, Ilocos Norte was operational November 2014. The NLR wind farm in Pagudpud is able to provide livelihood opportunities to families from its host barangays. The solar site of Equis Energy in Corimao, Ilocos Norte was commissioned on February 22, 2016, and it's commercially on February 29, 2016. There are 64,800 panels with a total capacity of 310 watts per panel. The figure above is one of the wind turbines of North Wind built around 14 years ago. Recent wind turbines built are already much bigger. The height of 70 meters is equivalent to a 23-story building. The hub diameter is equivalent to a wingspan of a 2 Boeing 747. The human height is highlighted in a yellow at the bottom of the turbine for comparison. With the influx of tourists in the localities of the renewable energy sites, the local entrepreneurs of souvenir items and sellers of agriculture products has suddenly sprouted. People are selling onions and garlic. Others are making wooden replicas of the wind turbines decoratively adorned by pebbles and seashells. Cafes also emerged to serve refreshments to the tourists visiting the turbines. Moreover, men and women and children set up stands along the roadway to sell garlic, fresh honey to increase income and revenue. Others have become local tourist guides. This study determined the extent of residents' livelihood transformation in Ilocos Norte with the integration of tourism and renewable energy through principal component analysis. Specifically, the research sought to know the socio-demographic profile of the residents at the wind farm and solar sites in Ilocos Norte, to know which livelihood as these sites progress or regress because of the integration of tourism and renewable energy. To what are the effects to the livelihood? It also specifically aims to determine whether tourism complements the residents' livelihood transformation. Finally, it aims to know the residents' perception towards integration of tourism and renewable energy. Sampling survey was used to gather data required for the study. In finding the right sample size on barangay, proportional allocation was used based on the number of residents of the town with 500 sample size. Descriptive analysis composed of frequency percentages was used to determine the characteristics and distribution of respondents based on their socio-demographic profile. The perception of the residents on the economic and sociocultural effects of tourism and renewable energy integration were classified and gathered through a Likert scale of 1 to 5, from strongly agree to disagree. Results were summarized and the resulting averages were interpreted. Principal component analysis was applied to the perception of the residents of the impact of the tourism and renewable energy integration with the components coming from economic and social-cultural aspects. Principal component analysis in the livelihood transformation takes its starting point from multiple dimensions or constructs. First is the income or the economics aspect, and second is the socio-cultural, with only 2 statements per factor for evaluation. These statements are represented by the column vector shown on the screen, where n is the number of samples of the statements. The statements extracted from the number of respondents m. The entire ensemble is compactly represented by n cross m matrix. The derivation of principal components is based on the assumption that the signal x is a zero-mean random process being characterized by the correlation r sub x equals e as a function of x times x raised to t. The principal component of x results from applying an orthonormal linear transformation. Psi is a matrix of psi sub 1, psi sub 2, up to psi sub n to x, so that the elements of the principal components vector W is equal to the matrix of W sub 1, W sub 2, up to W sub n, all raised to t, becomes mutually uncorrelated. The first principal component is obtained as a scalar product. W sub 1 equals psi raised to t sub 1 multiplied by x is chosen so that the variance of W sub 1 is maximized subject to the constraints that psi raised to t sub 1 times psi sub n equals 1, the maximal variance obtained when psi 1 is chosen as the normalized eigenvector corresponding to the largest eigenvalue of R sub x, as denoted by lambda sub 1, and the resulting variance is subject to the constraint that W sub 1 and the second principal component W sub 2 should be uncorrelated. W sub 2 is obtained by choosing psi 2 as the eigenvector corresponding to the second largest eigenvalue of R sub x, and so until the variance of x is completely represented by W. Accordingly, to obtain the whole set of n different where big lambda denotes a diagonal matrix with the eigenvalues small lambda sub 1, sub 2 up to sub n. Since Rx is rarely known in practice, the n cross n sample correlation matrix defined by the formula shown on the screen replaces Rx. The above derivation results in principal components that characterize respondents' answer correlation. However, it is equally useful to define an M cross M sample correlation matrix to characterize correlation among statements. In this case, the principal components are computed for each sample on the formula on the screen, where x is a function of n is equal to the matrix shown and psi raised to that t is the eigenvector matrix of R sub x hat. This slide shows the sociodemographic profile of the residents. For gender, the male respondents are almost equal or the same to the female respondents. As for age, 1/3 of the respondents are 36 to 45 age bracket, followed by 26 to 35 years old, and then 45 to 55. As for the civil status, most of the respondents are married. For the religion, all respondents are Christian, wherein around half of them are Roman Catholics. For the educational attainment, 2 out of 5 respondents are high school graduates. Prior to the renewable energy sites installation, majority are self-employed, farmers and fishermen. These are several few who are into salt making, furniture making, and hollow blocks making. After the renewable energy installation, there are drastic changes in the types of occupation of the residents. Although the level of self-employed people did not vary so much, there are other occupations that drastically change. Some are abandoned. People abandon farming, fishing, livestock, poultry, hollow blocks making, and salt making. People went for occupation in the private sector, utility worker, tourist guides, and laborer on the local infrastructure. Unemployment went down. With tourism and renewable energy, most residents agree that the integration has not only promoted the place to be visited by tourists but also helped initiate small businesses and additional profits to the local. They generally agree that the renewable energy presence has created more jobs, attracted more investment, more revenues from their livelihood. The social, cultural effects on the renewable and tourism integration, the residents have contrasting views. Summarizing the results, the residents moderately agree that the integration changed the traditional livelihood, although they agree that the integration has enhanced their livelihood. They disagree that the heirlooms and other cultural livelihood lost significance. For the economic statements, the residents all agree with all the statements shown in this. The results of the principal component analysis showed highly significant results on the 4 statements on the table below. It shows that the tourism and renewable energy has given positive impacts to the residents in terms of better income or economics and socio-cultural aspects. For the conclusion, the integration of renewable energy and tourism has transformed the livelihood of the residents living near the renewable energy sites in Ilocos Norte. Employment has drastically shifted from agricultural based subsistence to co-occupation primarily catering to the needs of the tourists. Analysis of the resident sentiments using principal component analysis shows that the integration gave the residents more livelihood, revenues, and more spread income distribution. Despite of this, the PC also shows that the residents foresee that the integration of renewable energy and tourism will not cause a commercialization and make traditional cultural livelihood lose significance and will not cause rapid cultural change. So that's wrap up my presentation. Thank you very much. Maraming salamat po. Good day.